With a basic master cylinder in the braking system, any loss of fluid, say because a component fails, could mean the whole braking system fails. To reduce this risk, modern vehicles must have at least 2 separate hydraulic systems. That's why the Tandem Master Cylinder was introduced. Like 2 single piston cylinders end to end, a tandem cylinder has a primary piston and a secondary piston. Each section of the cylinder has inlet and outlet ports and compensating ports. There can be 2 separate reservoirs, or just one, but it is divided into separate sections. When the brake is applied, the primary piston moves and closes its compensating port. Fluid pressure rises and acts on the secondary piston. It moves, closing its compensating port. Pressure builds up in this circuit. Both pistons then move and displace fluid into their separate circuits and apply the brakes. If there is a failure in the secondary circuit, the primary system continues to operate normally, but with increased travel. If the primary circuit fails, no pressure is generated to move the secondary piston. So a rod attached to the front of the primary piston will push the secondary piston directly so that it still operates. A switch can warn of loss of pressure in the front or rear circuits, or one that warns of low fluid level can be fitted to the reservoir. The Tandem Master Cylinder, just like the single piston Master Cylinder, can have problems with the low pressure area developing when the piston returns quickly but the fluid lags. The Tandem Master Cylinder overcomes this by using grooves in the side of the primary cup. These grooves allow fluid to flow from the inlet port into the low pressure area.